We have selected U.S. Gypsum's plant in Boston to demonstrate its similarities with the disposal of wet gypsum board with that of sludge-derived fuel. Here we see the loading ramp that is utilized by the front end loader to charge the feed bin, shown in the center of the screen. The raw feed material is fed horizontally out of the storage hopper and drops down into the Williams No. 230 impact dryer mill, where 1100 degree Fahrenheit hot gases mix to produce a violent fluid bed dryer and grinder. This grinder is being driven by a 75 horsepower motor at 1,800 RPMs. So that we may visualize the similarities of sewage sludge disposal and wet gypsum board, this man is sorting through a pile of raw material composed of 40% moisture that reacts similarly to that of sewage sludge. The front end loader has just filled this feed hopper with the wet raw stock. And now we will look down inside the feeder to watch the mixing and feeding action of this variable speed feeder. The inventory of wet raw stock is continuously and uniformly fed from left to right by means of the multiple screws located at the bottom. These screws deliver the feed into the turbulent fluid bed of the impact dryer mill and also form an air seal. Since the impact dryer mill is a negative system, there are no egresses of gases. All leaks are inward to the system, thus maintaining a clean environment. From the impact dryer mill, the dried product is then air conveyed up and over to the cyclone separator, where the solids are removed from the air system. Here again we visually traverse from the fluid bed grinding system up and over to the cyclone, where the cyclonic action takes place and the solids are centrifuged out of the airstream and valved out of the system at the bottom by means of this rotary valve. The dry solids now fall by gravity down this chute into a secondary grinder located below. Through this opening we can see the product as delivered by the cyclone that is now dropping into the secondary grinder. This grinder now produces a fine dry powder that would be suitable as a fuel. The product has now been air conveyed into this holding bin. The feed material has been dried from 40% down to 1% H2O and is now at a fineness of 80% minus 200 mesh. The product is now recovered from the holding bin by means of a variable speed screw conveyor. In your mind's eye, imagine that in a sludge-derived fuel installation, that this product would be recovered in the same way and fed into the combustor incinerated located below by means of this screw conveyor. And this is the Williams combustor incinerator located below. The fuel would be direct fired by this combustor so as to produce the hot gases necessary for drying. The outlet gas temperature would be controlled so as to meet local Department of Natural Resource requirements. The design of the sludge-derived fuel system lends itself to distributive control by means of a Williams dual-line display computer shown here.
The ability to monitor or look at any setup parameters at any time, and also display any alarm messages.
U.S. Gypsum Corporation of Boston, Massachusetts has installed an innovative process to convert waste wallboard, wet and dry, to a usable product that can be used and recycled back to their use. The beginning of the process, as shown here,
and as that material comes down, it now goes down the chute that we showed you earlier, and this is discharged below. But when this pulverizer is moved up into position, with these hammers rotating at speeds, they will shred the raw material, and it will then discharge down that chute into the conveyor that we looked at for discharge evenly into this hopper. Put your hand up there. Okay. Put your hand on the cutting edge. For this feed conveyor, right now this is the bypass chute, which is utilized to bypass the Williams mill till it goes in operation. The material drops straight down into this bin, which we were looking at, where material is run over by the bulldozer and then fed to the Williams impact dryer mills. In operation, this conveyor will feed underneath a discharge chute, shown to my right, which is underneath the Williams primary shredder. That discharge chute will feed onto this conveyor, and it will make a distribution inside this hopper. So this conveyor will feed across and will eventually be used to fill the bin. Alright, would you pick up some more material for me? This is the feed. Pull some of that paper down, would you?
Paper?
The paper, yeah, right.
the feed is then brought to inside the plant, delivered by a 5 cubic yard bucket front end loader. The feed is delivered to this feed hopper, which is mounted on top of a JC steel feeder. The material is then augured into the impact dryer mill on a continuous, even basis. The impact dryer mill here, as shown, is our model number 30NF. The JC steel feeder used for this system is their 44C. This view shows the feeder in operation. Notice that the feeder handles the wet sticky material, including the paper. Any oversized paper is reduced also by the feeder. Hot gases are provided by a Williams number 12 million BTU gas and oil air heater. Here is a view of the controls for the air heater. The system is now operating with a input temperature of 1068 degrees with a over temperature control of 1240. Here's an internal view of the control panel showing the Honeywell flame safety. Hot gases are drawn into this unit by virtue of a prime air mover material that is augured down through the through the JC steel feeder and into the impact dryer mill, are removed by air up through a classifier which separates the by differential weight the paper and the gypsum. The paper and the gypsum report over to a primary cyclone collector and is disengaged from the air, and the material reports to the rotary valve mounted underneath. The rotary valve feeds an inclined screen with a diverter gate mounted at the back. The inclined screen has a quarter mesh screen in it to separate the paper. Here's a view of the paper and gypsum as it is being fed onto the screen. Only the fine gypsum can be separated from the paper. The resulting effect, because of differential densities and utilizing the drying capability of the impact dryer mill, 95% of the oversize is paper and 95% of the undersize is gypsum. The plus discharge, or plus quarter inch, is mostly paper. In this view you can look at the paper, but after this film was made, the intent was to put in a baler so that this paper could be sent to a recycler. The undersize, or mostly the gypsum, that reported underneath the screen was then directed down to a secondary grinder to achieve the guarantee of 90% minus 100 mesh. Here is a view of the secondary grinder. Material in this grinder is removed by a high-pressure pneumatic system. The discharge of gases from the cyclone report over to a dust collector. This view shows a stainless steel Flex Clean conveyor. The discharge of the Flex Clean to a rotary valve and then to a small pneumatic conveyance system, which in turn reintroduces the dust back into the cyclone collector. This method of discharging allows most of the material to report back and eventually find its way to the secondary hammer. The material that is finally ground, the gypsum, is then transported pneumatically to a large receiving bin mounted high up into the bore plane. The pneumatic line is shown here, where the material is being conveyed up and into a filter receiver. The discharge of the filter receiver on the air aspect, is out through the top. The discharge of the solids report to a rotary valve and then are directed into, by gravity, to the holding bin. The air that is discharged from this unit goes to a Roots Connerville high pressure pump, and then it is pumped to atmosphere through a silencer. This view through the manhole cover shows the material as it is falling, free falling, inside the bin. The purpose of this bin was to hold material while it was waiting for processing in the kettle. Here's a view of the material, the gypsum, as it is being discharged from the bottom of this bin. The discharge conveyor is a ribbon type conveyor hooked to a variable frequency drive. On a demand basis, this material can be discharged as much as 5 to 6% of the total gypsum that's being fed to the kettle. The discharge from this screw is down to another cross conveyor which feeds the top of the kettle. The entire system is controlled by a Williams 200 series control system. This control panel utilizes a small computer and allows easy access to all of the variables. Even the variables can be changed remotely by the use of an RS-232 port and modem. This view shows the handheld terminal that can be used by field operators. This view shows the two-line display.
Can you change any of the functions?
We have the ability to monitor or look at any setup parameters at any time, and also display any alarm messages.